Hello everyone, my name is Harsh and I'm an undergraduate student from VIT Pune, India. My presentation topic is about SSH or Secure Shell, but before that, let me give you an example. You can also consider task 2 for this. I'm showing an app that me and my friends built. So let's say uh, you have an application, Liquid Galaxy application. So first of all, you have a mobile phone, and then you have your Liquid Galaxy rig, which would be mostly consisting of three virtual machines or physical machines, does not matter, running the Liquid Galaxy system, one of which would be the master machine, and you will have two or more slave machines. The mobile app could be running on your physical mobile phone or an emulator, does not matter. So this application was about flood mapping. It was mostly for study purposes or during a disaster for controlling or managing the crowd. You can say it had two applications. First one was the user app, where a common user can ask for help or find nearest hospitals or safety zones that are declared on the map. You can basically find your way to that place. And this is the main application, admin application, you can say. This application is used to see the impact of the flood. So this is the state of Kerala in India. It has been suffering from floods since many years now. So these are different kinds of things that we had plotted here. This is the impact of the flood on vegetation. So all this blue region was under the water and affected. Similarly, these were some households that had requested an emergency SOS. So basically, an admin could see all of this happening live during a disaster on their screen. But when we talk about all these things, even in task 2, we have to create a polygon or a 3D polygon right now. It's not just magic that we press send KML and it just appears on Google Earth, right? SSH is one of the key factors that play an important role in all this communication. So that's why it's an important thing to know about, to learn about. So let's begin with the presentation. First of all, what is SSH? So SSH or secure shell is an encrypted and secure protocol that is used to create connection between a local computer and a remote server. You do not need to overcomplicate it. It's just basically a system through which you can send uh, or receive commands and information from your computer to another computer. That's all. So you need to ask some questions or you need to have some questions. How do we configure a server remotely or any other computer? How do we access it? How can we make sure that our server is healthy or working fine? How do we transfer files from our computer to server remotely without using any third-party applications like Google Drive or Dropbox? And how do we run commands over there and all? Main question should be from the Liquid Galaxy perspective, since we are here for that, which is we have a main machine LG1 running somewhere, anywhere in the world, does not matter, and it runs Google Earth Pro and other dependencies, and we have slave machines that are connected to a master machine. The question is that how can we remotely send KML files and display logo, execute various kind of commands to clear logo or clear the KML file directly from our Flutter application? So SSH is the answer, you must have read anyways. So I think you might have understood that why we need to learn about SSH. These are few points that you need to always remember. SSH is useful for secure communication. We have a slide about why it is secure. You'll get to know. So again, yeah, it helps encrypt data and protect your communication through any kind of sniffing or spoofing attacks. Then again, system administrators use it to monitor, update, and troubleshoot any systems. You can perform things like file transfers through it. This is the best point that I like about SSH is that Git uses SSH for things like git pull and git push. You have a remote repository somewhere lying, you don't care. And when you fork it, you clone it on your system, you make changes and then you push it. The world is just supported by GitHub, and for all these commands, Git uses SSH, so that's a wonderful thing. And again, you can automate CI/CD pipelines. You can just write your scripts and keep it, leave it somewhere, store it somewhere, and you can just execute it remotely whenever needed. And the main point is that from Liquid Galaxy context, it is essential for sending various commands and KMLs, logos, clearing them to the Liquid Galaxy rig. Now, let's just study in short about the brief history. I hope everyone likes history now. SSH was created in 1995 by Tatu Yolin or Yonen, I don't know. Please correct me if I'm wrong. He was a researcher at Helsinki University of Technology, and the motivation was that after a sniffing attack that exposed a lot of insecurity in the telnet and our login protocols. So I'll just briefly explain what had happened from telnet's perspective at least. Telnet was earlier used to, access machines remotely. But what happened was this was the early time of the internet, and internet was fairly young, you can say. During that time, there was not much awareness about encryption and all, because hardly a very few universities, mostly in the West, had access to computers anyway. Uh, Soon, the you can say production of computers increased, they became more accessible, and so the users kept on increasing. Now, what some smart people did, smart but bad people did, is the communication that took place from one computer to another through the telnet protocol was not encrypted. So basically, if I log in to say youtube.com, and if my communication was not encrypted, someone would just sniff out my communication that takes place. Now, sniffing is a very common type of attack, and you can literally execute it using max to 3 to 4 lines of code, and you are just sniffing someone on your network. So it's that easy. So you can actually monitor the communication that takes place, and if it's not encrypted, you have their login credentials and credit card details and whatnot. So there were some major attacks that had taken place. Basically, they just exploited the protocols, and so SSH1 was first released in July 1995, and it was fairly adopted very quickly, and soon there were SSH Communication Security Foundation. They expanded on the protocol, and today, as you know, as you have seen in the previous slides, that SSH is a global standard, and everybody, pretty much everyone, uses it, whether they realize it or not. Now, this is what SSH looks like. I think most of the people who are from a computer science background might have seen this. It's basically user SSH space, yeah, type the username at the IP address of the server. So you can type this command. Like obviously you have to replace these template literals with your actual IP address and username. And when you write this command, you can connect to a remote server. Now, of course, you cannot directly connect to any kind of server that you don't own or don't have access to. So there are some security features like typing in a password or something, which we'll see in further slides, that takes place before you can actually execute commands on your remote server. In fact, the task to application, which was mentioned earlier, you have to enter an IP address, port number, as well as a password on the settings page. So this is the backend working of that application. Now, there are 4 steps on how SSH works. First is a TCP connection setup. Next is SSH version check. Then is the key exchange process, and then we have client authentication. It's not very overwhelming, but just bear with me for some time. We'll learn about them one by one. I'll try to explain it in as simple as I can. So the first step is for TCP connection setup. TCP is transmission control protocol. Now, before a client communicates with the server, there are a few steps that need to be established. So it consists of a three-way handshake. Three-way handshake is nothing but my local computer. Uh, Here we have to assume that we have typed out username at the rate some kind of IP address. So what happens is we send a sign flag or a synchronized flag or a variable or a packet to that particular IP address, and we assume that the server is on that IP address. Then if the server is there, uh, he will send a synchronous flag plus an acknowledgement that yes, I exist. And then the local computer will send an acknowledgement back saying that okay, I see that you are there, I'm here, so let's communicate. Now, the second step is the SSH version check. It's basically like if don't speak Spanish and I can speak only English, English and Hindi, let's say, and I need to communicate someone in France and they only speak French. We cannot communicate. So you can consider version check something like that. You need to see if it's compatible to communicate on that particular version. So in this step, basically, we just check the version numbers and if it's suitable to communicate. All right. By the way, if either of them does not match, we terminate the connection. You'll probably get an error message that the version check failed or something related to that. Now, the third step is the key exchange process. This is very important step. Uh, in layman terms, it's just like let's agree how to talk securely. This is for the encryption and security perspective, you can say. Uh, at this step, you need to understand that step one and two have been executed. That means both I and the person I wanted to talk to can speak English or Hindi. So we have agreed to communicate in one language. That's fine. But now we need some security features. So for that, you need to create a key pair based system. What happens is in the step one, your algorithm does not really matter. Algorithm is basically just application of some mathematical functions. I have an example to show you that. Look at this. Look at this image. All right. If I want to say hello to that French person, I cannot just directly say hello because someone third person who is besides me can also understand what I'm saying, right? They can also hear hello. So what we do is we encrypt whatever the data I'm transmitting or whatever the commands I'm transmitting, or whatever the message I'm transmitting to that person using some mathematical functions. They vary in their complexities and computation power. That does not matter for us right now. What we need to understand is our message is converted into some kind of ciphertext or a code, and then the user who actually is meant to view that message will decipher it or decode it. Okay, so encryption and decryption takes place. So in step one, client and server both select a way of encryption or decryption. It's just agreeing on a common pattern to encode and decode your messages. All right. Now, in step two, both the sides have agreed on some kind of algorithm. So once we have agreed upon a common encryption method, we share a kind of a public key, you can say. It is just a result of some mathematical computation. So all the messages that you send are signed by a private key and then using a public key. A public key is sent through the network and the private key is formed by performing that mathematical calculation and never shared or transmitted to each other. It's assumed that both client and the server have computed that value and they have stored it with them. It They do not transmit the private key. Only the public key is sent, and after that is done, trust is established. So the result is that commands and the secret keys are sent only to the correct server. Next, and the third step is just basically an example of the previous slide. This is example of SHA-2266, and again, you do not need to remember what algorithm is used. the client has shared the supported algorithm. The server will agree or don't agree on that algorithm, and then if they do not share a common method of encryption, then you can just reject the connection. Mostly, we agree upon a type of algorithm. You can also manually configure it. So after that, we have chosen an encryption algorithm, this one, and then we compute the private key and public key that I explained. Once that is done, you establish a session. So every packet is encrypted and integrity checked. That means it is correct, because if it's not, then your mathematical computation, that answer that you get, will be wrong. So if your answer is correct, that means you have the correct keys, and whatever transmission had taken place, that was correct. Now, this is the summary of the key exchange process. And if you even understand this summary, it's fine. You do not need to remember it in depth, but I would recommend you reading about it. It's very interesting. So we agree upon an algorithm, then we verify the server, and then we create a shared secret, which is that public key, and then we create a session identifier. It's similar to the sessions that we established on a website, let's say. Once that is established, we derive the session keys, the private key. This is the last step, which is client authentication. So by this step, we have to assume that some kind of session has been established between the client and the server. Now, in order to execute commands on the server, the client needs to authenticate itself again, which is like to say that I am the client and I have the right to edit or take control of your machine. For that purpose, we need to enter either a public key or a password or a keyboard interactive. This is not always required, but even if one method fails, we can try the next method. Uh, Basically, for public key, what happens is you can download a file when you create or configure a secure shell network. And if you download that file on the client side, and you try to connect to a server via SSH, that file is automatically used as something sort of a password. So you do not need to enter your password each and every time. That is very convenient, but again, there are a lot of memes around this that you can never ever lose that particular file, because if you lose that file or the file falls in someone's hands, then they can basically just connect to your server without entering any kind of password. So this diagram is like a small example of the fourth step. The server says, please share the password. You can share the public private key file or the enter the password. Then the user has entered the password. If it's wrong, we give an error. If it's correct, the password is correct, and successful session is established. So you can execute commands or do whatever you like. This is an elaborated example. So the local computer sends the public key to the remote server. Remote server then sends the challenge. This challenge is referring to that mathematical computation that I mentioned. So you perform some kind of mathematical computation. You do not need to care about that as of now. And then we sign it using the private key. As I said, only if you have the correct private key, you will be able to solve that challenge. Then we send the signed challenge to the remote server. If your computation was correct, that means you're authenticated, and if your computation has failed, that means you are not a legit user and your communication will fail. So all of these steps, which I have explained in short, these actually go up to vast amount of depth. These things make your connection secure. SSH and Liquid Galaxy, the main purpose of this presentation. Let's consider the task 2. We need to send and edit KML files, erase them, send a logo to the RIM. And for all these purposes, secure shell connection is established between your mobile application built using Flutter or any other framework to your LG1 machine. So this is a flow that your application will connect to a master, and master is connected to multiple displays or slaves. So Single SSH connection is established from the master and it propagates to your slave nodes as well. So even in inter what you can say liquid galaxy machines communications, SSH plays a part. Now this is a very important directory that you need to remember. Like not exactly learn it, but you always have to keep this directory in your mind. This exists in LG1. So this is kind of file server or a directory that the Liquid Galaxy system is constantly monitoring. So the query.txt is constantly being polled by a PHP server. Uh, this is something that we do not configure generally. It's there by default when we set up the Liquid Galaxy system, probably in task 1. So the query.txt is kind of a place which is constantly monitoring for changes that takes place. So if you want to execute some kind of commands from your Flutter application to query.txt, you can do that via SSH. Again, you have synchronized multi-screen control. You already know that, and then you can display logo disaster mapping like I showed you previously. Then rescue markers and tour visualization and all is possible. These all things are just executing of some kind of commands, Linux commands. That's all. Port number 22 is for SSH. Port is just a channel of communication. Like on a highway, you might have multiple lanes, right? So lane number 22 is for SSH generally. 192.168 is your local network that you configure. Again, this is task 1. This does not matter right now. Strict host key checking is disabled for trust environment. This is again an authentication feature that you can use. Then collection validation before operations happen, detailed error messages, exception propagation. These things are like features that you can always use. Of course, it's always best to have a validation and printing of error messages. Then coming to KML basics, because we send and receive KMLs, we'll understand in short what is a KML. KML is keyhole markup language. It is an XML-based format used to represent geographical data in Google Earth and other platforms. It's just a common language that is used to display some kind of thing, shape, or anything that you can imagine on the Google Earth. All right. So that's about KML. For task 2, we have to handle sending, clearing KMLs, managing logos, and understanding KML is crucial, like I explained, because it's the language that Google Earth Pro and Liquid Galaxy Lyrics understand. This is the demo flow. You have an application UI, a Flutter application. Your app sends an SSH command to your LG1 system and it's being polled for changes. So once you create a change, your change is reflected on Google Earth. Next slide. These are a few example commands that you can try out. I'm pretty sure by now most of y'all might have tried some. This is a cpkml file. Uh, it's a Linux command by the way. CP is just a Linux command and it sends a copy of a KML file from your local machine to Liquid Galaxy's directory. Now, why we do this is because in /html /kml /kml number dot kml is or are the files that are responsible for your KMLs. So I think in task 2 we have to send 2 or 3 KMLs, right? So when you press send KML1, your KML1.kml is being edited by some kind of Linux command or bash script, and that change that happened in KML1 is responsible for displaying that particular KML. If you press KML2, send KML2, then /KML /KML2 dot KML is being edited. So in this way, you can reflect your changes or show display your changes on your Google Earth using your mobile Flutter application. Second is just you can say a bash script. You can automate this like it's just a written set of commands, multiple commands, and you just need to execute it once. So instead of you typing each and every command again and again. You can execute that script, which will execute all the commands in one shot in a particular sequence that you wish. Then for clear KMLs, you can either delete that KML file, and you can also replace the current KML code, let's say 3D polygon, to the default KML structure, which is kind of blank. You can make that file blank. So for all these things, you again execute just basic Linux commands. You don't have to write the command each time. You just press that button, right? So in the backend, you have while you were coding, you might have written these commands, and they are being executed on your LG1 machine. This is a common issue that I have picked from LG Wiki. Time is running out. I'll quickly explain this. So when you try to connect using LG relaunch, or when you start a Liquid Galaxy system after installation, uh, many people have often faced this issue, saying permission denied, please try again. What happens is sometimes, most of the times, you need root privileges to execute or to get full access of the system. This is not a default behavior in SSH. So by default, we log in as a user, but we are not a root or an admin user, which gives you the highest amount of privilege to execute commands or view directories. This is intentional for safety purposes, because again, root has no restrictions, so you want your system to be safe, and there are some workarounds for this. Let's see it in the next slide. You can either log in as a root. You can run privileged commands using sudo reboot. You can automate it with SSH pass. You can read about all these things from Liquid Galaxy Wikipedia. I referred it from there itself. So again, the wiki also says that contributors often use SSH pass to run commands like LGD launcher reboot. It requires admin privileges to reboot your machine, right? No one randomly should be able to do that. So you can also refer to LG command repository. It lies in this directory, particular directory. It has pre-written pieces of code or shell scripts that you can refer. Now, this is one last thing that I would like to explain it to you. Not really explain, but introduce it to you. It's a wonderful rabbit hole that you can learn about if you find it interesting, of course. It's about reverse proxy and tunneling. When we generally make a website or anything, let's consider a website. It runs on, so let's say, localhost 3000 or localhost 4000 when you run a development server. But what if you could share this localhost 4000 to your friend who is in another city? It won't work, right? Because localhost is something that belongs only to your particular system. But you can actually share that using these concepts. They are really interesting. So reverse proxy is something like a server that sits between uh, client and the server, the backend server specifically. If you might have heard about load balancers, they are kind of reverse proxies. So when a user using their mobile phone or laptop connect to some server, let's say Amazon.com, you don't really access a server from Amazon. uh, this is a good practice because it ensures safety, and it does not reveal much information about the server. You access a load balancer. You can read it here. The load balancer will automatically allot you a server, and the communication will take place from you to the reverse proxy and with the server. So you technically cannot really access a server at any instance of time. This is good because you can cache it for good performance. You can hide server details. You can use SSL, secure socket layer, and transport layer security termination. Uh, in this way, you offload encryption. Basically, you can choose not to use these protocols for your connection between internet and the reverse proxy, since you can never really access any kind of servers. Then tunneling is a similar concept. It encapsulates one network protocol inside another to securely transmit data. VPNs are kind of similar thing. So if you look at this diagram, VPN, you can connect to a VPN server, and VPN server will connect to different kinds of websites on the internet. This process is similar to tunneling. You can also set up your own tunnels and all for network purposes. A lot of people actually do this for if they have a big office and they want an internet network that is just an internet of their own personal devices and not connected to the outside world. You can use these concepts there as well. So I would love for you to learn about this and share it with me also. This was it for my presentation. If you have any feedback, you can share it with me on the Discord or anywhere you'd like. And if you have something more to share or add on in these things, feel free to do so. And thank you so much.